Hi everyone, it is the Level 2 Chemistry exam TGC 2023. This one's organic and this one is question 3. The one I've just marked, that's where I'm going to start. Tricky question this one. So the first question here, we've got to identify A, B and C. We've got some colour changes which we're probably going to expect to get, possibly some solubility. Boiling point was probably the tricky one there, and we did need to use the boiling points here. So we had to start by identifying A, B and C and then saying how we did it. So the easiest one that most people got first was using the colour change. So if something changes colour with dichromate, this is an oxidant. So it oxidizes things, and we should know that it oxidizes alcohols only. So one of our substances only is an alcohol. So B is going to be propan-1-ol. A couple of you didn't use the actual names in here. It's the easiest thing to do is just use the names up here and put them in there. And if you don't know, do have a guess. It's not hard to do that. A and C were the tricky ones. Both remain orange, so obviously cannot be oxidized. And the solubility is the other thing that we could have looked at, but both are insoluble. So we actually can't use the solubility to differentiate between A and B because they're both insoluble. You could have got some marks by explaining the solubility, and if that was the case, you would have needed to write that water is polar and that alkanes are non-polar. Remember, anything with just carbons and hydrogens is non-polar. And alcohols with this little electronegative oxygen in them, they have got a bit of polarity. The length of the carbon chain does influence the solubility. However, in this case, it's quite short. So we're just going to say that it is polar. So the boiling point here is the key one. There's a big difference between C and A. So this is a very low boiling point. This is a reasonable or higher, let's say, boiling point. So we've got to have a look at propane and pentane and look at the difference. And obviously the difference is 3 carbons in the chain, 5 carbons in the chain. So what we needed to say there was that the longer the carbon chain, the stronger the forces between the molecules, just like what we learned in bonding. So sometimes we have to take some of our knowledge from another paper and add it into here. So how did I identify A, B, and C? I would have started with with B. Let's start with B. The only substance to show an orange to green color change with dichromate was B. This must be the alcohol. As alcohols can be oxidized. And the question says that we need to use relevant equations, and some of you did forget this, unfortunately. This is the equation we need. We can't really write an equation for solubility or boiling point, but we can write an equation for dichromate here. So we should have written propan-1-ol. And note, I'm going to make sure all my H's are in. And I like to draw extended structural formula so I don't make silly errors. And I can do one of two things here. I'm just going to put the dichromate on the arrow. Probably should heat it as well. And I'm going to use the same number of carbons. And oxidation, the definition most simply is adding oxygen. And our carbon number is not going to change. It's quite an important rule to remember at level 2. No change in the number of carbons. But the functional group does change, even though it stays on the same carbon. And the only functional group we know that has more oxygens in it, excuse me, just rub this out a little bit here. The only one that we know is the carboxylic acid. If you look at that, it does have an extra oxygen in there. So that's my equation. You would not have been penalised for putting plus Cr2O72-, that's fine too. So that's our B. We could have also said that it was also the only one that is soluble in water. We didn't need to say that though, because we've identified it with the colour change, and that's the better way to identify it anyway. It's much easier. So we now actually had to head to identifying A and C. So I would have said both have no reaction with dichromate, and it actually is good to state what that no reaction observation is. Orange stays orange. The other thing that we got a little bit wrong is that we wanted to say that it was the alcohol that changed from orange to green. So all of our organic substances are colourless. If they react, it's the other thing that changes its colour. This thing here is orange, and when it reacts, it changes to green. You will, students at TGC, you will get more familiar with this because that's the last internal that we're going to do coming up starting next week. Right, so A and C neither have a reaction with dichromate. Orange stays orange. Alkanes cannot be oxidized. Okay, both are insoluble in water. And we can say insoluble in polar water, as alkanes are nonpolar. We don't need to write much more than this in organic. If this was a bonding question and it was about why are things soluble, then we would have to expand this bit here and use our diagrams, but this is just a little bit more information here. So then we need to use the boiling points. So one substance has a lower boiling point, and this must be propane, as the lower, let's say the smaller the molecule, and in this case we can say 3 C atoms in chain, the weaker the forces between molecules, and the less energy to separate those molecules and turn liquid to gas. So therefore our propane has the smaller chain length, therefore the weaker forces, so less energy, so lower boiling point. And our pentane is the one with the higher boiling point for all the opposite reasons. And I'm just going to say, therefore, pentane is C. All right, I don't have to write all of the same reasons again the other way round. I've said why this one is lower, so I just have to identify. I don't have to write all those reasons again. That one was a tricky question, but quite a lot of you did a good job on that, so well done if that was you. Okay, so then we had a big elimination question. It does actually say elimination reaction. So the first thing I want to say to all of you is that if you do not know your definitions for the types of reactions, you're going to struggle. And that was where our issue was on the next page. So this is really important. So elimination is when we remove the functional group and a hydrogen from an adjacent carbon. Right, so I'm going to remove the chlorine from this carbon and the hydrogen from the next carbon, and I'm going to therefore form a double bond. If I remove those two, let's just redraw this, CH3, CH2. Now I've got CH, I've removed one of those, and here I've got CH2 because I've removed the Cl. So if you look at me redrawing this molecule, but what I have done is I've taken an H off this carbon here, and I've taken the Cl, or the functional group, off this carbon here. So look at what I'm left with. Therefore, it's pretty obvious when I look at it, I can make a double bond, and then all my carbons will have 4 bonds, which is what I want. This one here, it's the same. So I had to remove the chlorine, and then I have to remove a carbon from an adjacent, a hydrogen from an adjacent carbon. So I can either remove this one, right? So I can remove those two, or I can remove this one, right? And I have to know which one I remove to make the major product and which one to make the minor. So to make the major, because I am eliminating, which means removing. Eliminating equals removing. Some of you started to talk about adding something in. So in its simplest form, eliminating is taking away or removing. I'm not adding anything, that's addition. I'm not swapping anything, that's substitution. This is why the reaction type is so important. So I'm eliminating. I'm not going to change anything. Some people left CLs in. Some people wanted to put the OH from KOH in. That's substitution or addition, but this is elimination. So the taking away is poor gets poorer, not rich gets richer, because getting poorer is removing. Getting richer is adding. So getting richer goes with addition, getting poorer goes with elimination. So which one of these adjacent carbons is poorer? This one's got 2, this one's got 3. So this one is where the double bond will form in the major product. So in here, I want to write CH3, CH, CH, and CH3. And then, of course, I just want to make my double bond where I've eliminated this. The minor is removing these two here. So I get CH3, CH2, taken away the Cl, so CH, and then I've taken away a hydrogen there, so I've got CH2, so my double bond goes there. Right, over the page, and we had to now explain all that. And here is where most people who went wrong, you just needed to start with your definition. And actually, some of you who got a good mark for this, if you had have started with your definition, it really allows you to focus your answer and your wording on the most important things without waffling, without missing anything out. So, with reference to their structures, why does 1-chlorobutane form one product while 2-chlorobutane forms 2? Justify major and minor. Okay, so let's start with 1-chlorobutane. Okay, and I'm going to go elimination is the removal of the functional group. In this case, Cl, and a hydrogen atom from an adjacent carbon. Right, so in this case, 1-chlorobutane, let's just very quickly draw it up here. I'm not going to draw it properly. Right, there's my Cl there. Here is the carbon with the chlorine. There is only one adjacent carbon. This is not symmetrical. Lots of you wanted to tell me this is symmetrical. It's not. It's completely asymmetrical. And next year, if and when you do level 3 chemistry, that will be important. This is not symmetrical. So not everything can be explained by that. So the carbon with the Cl is only bonded to one other C atom. Some of you correctly said that was a primary haloalkane. That was a good piece of information to put in, but not completely necessary, but good. It's only bonded to one other carbon atom. Therefore, there is only one option for the H to be removed from. Therefore, and this is what I actually haven't put up here in my definition, elimination is the removal of the functional group, in this case Cl, and the H atom from an adjacent carbon to form a C to C double bond. It's pretty important there. So the carbon with the Cl is only bonded to one other carbon atom. Therefore, there is only one option for the hydrogen to be removed from. Therefore, one product, and it is butene. But for 2-chlorobutane, now this is an asymmetric and it's important. So if you look at this, here's my 2-chlorobutane. There are two adjacent C atoms, this one and this one. One of my suggestions is to number these as you would if you were naming it. So that would be C1, that would be C2, and that one would be C3, because that's 2-chloro, right? So then we can talk about these 2 carbon atoms using C1 and C3. And you could even draw a little picture like this, probably put your H's on if you were going to use this in your exam, and you could even label it so that the marker could clearly see what you were talking about. So 2-chlorobutane, the C with the functional group has 2 adjacent carbon atoms, and the haloalkane is asymmetric. So what that actually means in this case is that the 2 adjacent carbon atoms are not the same. If it was symmetrical, then those 2 adjacent carbon atoms would be the same, and they're not. So, and the haloalkane is asymmetric, which means the 2 adjacent carbons are different. Okay, so 2 products can be formed. That's your first piece of information. Then we did have to justify our choice of major and minor. So to form the major product, the hydrogen is removed from the adjacent carbon, adjacent carbon C3, as this C has fewer hydrogens than the other adjacent carbon. Which is C1. Right, so the major product is therefore butene. Okay, so it's formed between the, we've already defined up here that the Cl is removed, the functional group, and now we've said which hydrogen makes the major product, and then we kind of don't really need to say the minor product because it's obviously the other one and we've defined everything in here, but if you really wanted to, you could. The minor product is where the Cl and the H from C1, more H's, are removed to form the double bond. Okay, so just a little bit of clarity in there, and I think that really for me comes from clearly defining elimination at the start of your answer. I know most of you, or some of you, don't really want to do what we tell you all the time, but the reason I like to do this is because it means I am forced to think of the specific language that I need to use in my explanation. Some of you had the right idea, but you just were so vague that I couldn't find any marks for you. So that's my big takeaway from this, is to define clearly. Right, and the last one which people freak out about is the big table. And some of this you do have to use your memory for, the rest you can work out. So let's look at the things we've been given. 1, 2, 3 carbons, 1, 2, 3 carbons, 1, 2, 3. So all of my compounds are going to have 3 carbons. So I am going to put those in just to make me feel like I've got a good start. All right, so now I need to think about what I'm going to do here. So this is actually a great place to start, because I should know, and actually a lot of you got this, that a primary alcohol gets oxidized to a carboxylic acid. And I'm just going to keep that functional group on the same carbon. Note that I am doing mine really extended structural formula. Some of you did not do that. I know they didn't do it in the question, but you put extra hydrogens in here and you therefore got it wrong. So really look at it and learn to check 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I still make mistakes sometimes, so I think you probably might too. Okay, so then if you look here, look at these two here, you've got an amine group here. So you're forming, the other thing, make sure you look at the direction that your arrows are going. You're forming an amine. So I must be adding this on. And so most of you got the NH3. because obviously that's the functional group. The thing you do need to remember there is that it's in alcohol, not in water or anything like that, not aqueous. And it must come from something. I'm just going to put my H's in. It must have substituted for something. And the thing that it must substitute for cannot be an amine, because that's what we're making. It cannot be an alcohol, because that's down here. It's got to have some functional group. So how many functional groups have we learnt? We have learnt alkanes, not very reactive. Alkenes, no sign of a double bond in here. We have learnt alkynes, don't usually use those, but just have them in the back of your mind. Alcohols, it's not that because we've got an alcohol here. Amines, not that because that's the product of our reaction. 1, 2, 3, 4, 5. Carboxylic acid, not that because our carboxylic acid comes from something being oxidized. 3, 4. So the only one we've got left is a haloalkane, and that was the thing. So don't forget you've learnt 7 functional groups. The answer is going to be one of those functional groups. So if you're going to have a guess, please guess one of the functional groups you've learnt. Honestly, you'll probably get it. Cl, boom, done. Okay, so now these 2 arrows here, I've got to interconvert towards a Cl and then towards an OH. So this one here, I've got to have something with an OH in it. I'm going to go KOH there. The bit I have to remember, which is tricky, is aqueous or alcohol. This is a substitution, so it's aqueous. And actually, could I go back over the page? Oh, look. It even tells me back over here that KOH alk gives me the elimination. So use the rest of your paper to help you. All right. This is obviously a substitution because I'm replacing this with this. Right, so that should have been okay. Just go back and use your paper. This one here, I've got to obviously put a Cl in. This is the tricky one. We had to remember either PCl3, pickle 3, or pickle 5, or Sockle 2. Pickle 3, pickle 5, Sockle 2. That's a tricky one. That is a memorising one. But, you know, there's a limited number of things we've learnt with a Cl in them. Right, so here we go here. Right, so then KOH alk. Pretty much again over the page it told you that was elimination, and we've just written an entire question on it. Entire question. So you should be able to know that you are removing the chlorine and a hydrogen from an adjacent carbon. Obviously, this one is going to form a double bond. So that's going to make propene. And how do I take this to this? 1, 2, 3, 4, 5, 6 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. So I'm adding 2 hydrogens. And this is the memory bit. You have to remember the catalyst, platinum or palladium or nickel. Finally, down here, this is also a little bit tricky. We've got an acid and we've got a base. So actually, this is a proton donation question. Again, that's a little bit of chemical reactivity creeping into this standard. So all I need to do for an acid and a base reaction is to get rid of that proton, because that's what acids do, and that leaves me with O minus. I could have put Na plus in there, O minus Na plus. It is a salt, it is ionic. That's good. If I didn't put the Na in, I would have still got it right. If I do put it in, I need the plus. And that is about it. So I reckon have a go at these and don't panic. And just use all those things. The number of carbons doesn't change. The position of the functional group doesn't change unless we do a couple of reactions and we're determined to pick majors and minors. And you must make one of the functional groups that you've learned, and then you'll get it. That was very long for this question, but there was a lot to learn. So I will be coming back soon with, actually no, that's the end of the paper. That's question 3. I hope you've learned a bit, and please keep working hard and set your sights high for that exam at the end of the year. Freddie says bye.